The tree data structure. Imagine a tree, not the kind with leaves and branches, but a special kind of structure we use in computer science. This structure is like a family tree, where you have a bunch of individuals, we call them nodes, and lines connecting them, we call these edges. Now, in this tree structure, each individual or node is connected to other below it. It's like a parent connecting to their children, and those children can have their own children, and so on. This is why we call it hierarchical. It's like a family tree where there's a clear order and hierarchy. So, in short, a tree in a computer science is a way to organize data in a hierarchical, structured manner, just like a family tree helps organize family relationships. It's a useful tool for solving all sorts of problems in computing. So, we have got different ways of organizing data in computer science. You might have heard of things like arrays, linked lists, and so on. Now, these are what we call linear data structures because they store data one after the other, like a line of books on a shelf. Here is the thing. When you want to do something with these linear structures, like finding a specific piece of data, it can take a while if there's a lot of data in that linear structure. Think of it like finding a specific book in a long row of books. You have to go through each one until you find the right one. That can be slow, especially when there's a tons of data. But in our modern world of computing, we often need things to be fast and efficient. That's where trees come in. A tree is a different kind of structure. It's not linear. It's more like a family tree with branches going in different directions. In a tree, data is organized in a way that makes it quicker and easier to find what you are looking for. So, when we are dealing with lots of data and we want things to happen fast, we use tree data structures because they help us do just that. Here are some tree terminologies. Node. Think of a node as a building block of a tree. Each one holds some information and can point to other nodes. Now, some nodes are special. The ones at the very ends, they are called leaf nodes or external nodes. They don't point to any other nodes. But if a node has at least one child, we call it an internal node. Edge. An edge is like a bridge that connects two nodes. It's the line that says, hey, you can get from this node to that node. Root. The root is the big boss node right at the top. Imagine it as the head of the tree. Height of a node. This is like measuring how far you would have to climb down from a particular node to reach the very bottom of the tree. Just count the steps, or in our case, the edges. Depth of a node. Now, this is kind of the opposite. It's like counting how many steps you need to climb up from the root to reach a particular node. Height of a tree. This is just like the height of the root, or you can think of it as how deep the deepest point in the tree goes. Degree of a node. Think of this like counting how many rods led out of a tree. For a node, it is the total number of branches it has. Forest. Imagine you have a bunch of trees, but they are not all connected to each other. We call this a forest. It's like having several little woods instead of one big forest. And you can make a forest by chopping down the big tree at the top, which is like cutting the root of a tree. Let's talk about where trees come in handy. Binary search trees. These are like the Sherlock Holmes of data structures, and they help us to quickly figure out if something is in a set or not. Imagine you have a massive phone book and you want to see if your friend's number is in there. A BST helps you to do this super fast. Heap. This is a type of tree, but not like the ones you see in a park. It's more like a mountain. We use it for something called heap sort, which is a way to sort a jumbled up list of things. Tries. These are like special trees, kind of like a family trees but for words. Modern routers use them to figure out where to send your internet data. It's like a super smart postman finding the right mailbox for your letters. B trees and T trees. These are like the super organizers of the database world. You know how your parents keep all the important stuff in those labeled folders? That's where these trees do for that in big data, fancy databases. Syntax trees. Imagine you are writing a super cool program but you miss a comma or something. Compilers, the programs that turn your code into something the computers understand, use something called a syntax tree to catch those mistakes. It's like having a grammar teacher check your work.